Welcome to One Chemistry. Always try to do your best. Now let us see about 100 concepts in organic chemistry. We are seeing it as episode. This is the episode number 67. If you didn't watch previous episodes, I encourage you to go and see. Here we solve 5 problems step by step. Stay tuned. Let us see the first question. They are given the different carbonyls. Basically they are differ in the substitution. First one is the ketone, second one is ester, third one is amide, fourth one is acid chloride. 4 different carbonyl compound. They are asking CO stretching frequency. Here 4 choices are given. You have to find which one is higher and which one is lower. So from the question of carbonyl system and different functionalities, you might realize the question is really about functional group versus stretching. The answer is A. Let us see how. Here you should know the basic concept that electron withdrawing group increases the CO stretching, electron donating group decreases the CO stretching. The reason is the electronegativity creates the strong positive charge, reduce the bond length. Now let us analyze the 4 system. Here we have to analyze the extremes first. Amide is very low because nitrogen lone pair can participate. Here nitrogen and oxygen and chlorine have lone pair. But if you look at the electronegativity, chlorine is more electronegative than oxygen than nitrogen. So chlorine don't donate easily, but nitrogen can donate easily. So what really happens is it weakens the double bond. It will convert the CO double bond into CO, which is single bond. So stretching frequency decreases there. So the least one will be amide and the strong one will be chlorine there, because chlorine don't donate as well as it's highly electronegative. So the bond length of CO is less, so it's very high. If you look at between ester and ketone, ester will have higher frequency, the same region of chlorine. Oxygen is electronegative, it decreases the bond length of CO, so it has higher frequency. So if you look at the order, acid chloride will come first, then come the ester, then amine, then the ketone, finally the amine one. So the answer is clearly A there. Here the concepts you have to learn here is the atom with lone pairs near the carbonyl group decreases the CO stretching frequency. Let us look at the next question. They are given the diketones there. The starting metal is beta hetoester. The ester is ethyl ester. You are adding methyl magnesium bromide. They ask you to find the product. The products are mostly differ in the methylation and MgBr attachment. Whether the methylation happen at ketone or the methylation happen at carbonyl at ester, or methylation happen at alpha position, or methylation happen at beta position. There are many possibilities here, so you have to analyze which is which. From the question of multiple carbonyl and the attachment of methyl group, you might realize the question is really about regioselective methyl addition. The answer is B. Let us see how. Here Me minus is the reacting reagent, which is from Grignard reagent. It only attacks the carbonyl. So other answers are not possible. Other answers are given for confusion. But here again the confusion where the methyl group will attack, whether A carbonyl or B carbonyl. So A can lead to the product methyl attached to the carbonyl, and B also methyl attached to the ester carbonyl. So which will be the major? Here charge quenching is the key here. In B attack, that is the ester attack, you have the leaving group there. ETO elimination is there, it will be easy because it is a very good leaving group. So charge quenching is easy with the B there when compared to A. You may argue with electronegativity, but the charge quenching here is important to take the reaction further. So the answer is clearly B, where the charge quenching is important. So the answer is clearly B there. Here the concepts you have to learn here is the charge quenching. Here leaving group dictate the charge quenching. The created negative charge is quenched by leaving group. Here 3 hydrogens are labeled A, B, C. They are asking relationship between them, basically topicity, whether the hydrogens are anisotropic or diastereotopic or homotopic. Basically you have to find which one is which. From the bicyclic system and its hydrogens and the topicity, you might realize the question is really about position of hydrogen versus topicity. The answer is B. Let us see how. Here let us analyze all hydrogen to avoid the confusion. Normally you find the topicity, you replace with some common atom. Here I replace with X, so some atom X. So if you replace HA and HB, it has endo-exo relationship. HA if you replace, it will be endo. HB if you replace, it's exo. So endo-exo relationship, everybody knows it's a diastereomer. What is the relationship between HB and C? HB and C are similar atom because it has mirror relationship, or you can say kind of C2 relationship. So it's a homotopic relationship. So the answer is clearly B. Only correct fact is HA and HB are diastereotopic. Here the concepts you have to learn here is if hydrogen have mirror image relationship, most of the time it's homotopic. Second thing is if hydrogen have cis strands or endo-exo relationship, it is diastereotopic. Then let us look at the next question. They given the 4-member cyclic ester there with phenyl and isopropyl attachment. In first one, phenyl and isopropyl are syn to each other. In the second one, isopropyl and phenyl are anti to each other. Basically, they are differ in the stereochemistry. You are using LDA and propyl bromide. They are asking the product how the products are differ due to the stereochemistry there. The syn and the anti relationship, how it affects the product formation. Here they given the 4 facts, which is the reactions are stereoselective with PQ are same, or reactions are non-stereoselective with PQ are different, which is enantiomer and diastereomer. Basically we are playing between stereoselectivity and the stereochemical relationship is diastereomer and enantiomer. So from the question of stereochemically different compound and using LDA and propyl bromide, you might realize the question is really about reagent and its influence on selectivity. The answer is A. Let us see how. Here the answer A means the reactions are stereoselective and B and Q are same there. Let us analyze the same condition of different compound. In the first compound, first step we are using LDA and base. Base subtract the proton, you have the anion formation. Here the interesting case. Normally sp3 carbon has tetrahedral shape, but the anion is near planar shape, or you can say chirality is lost there. So wherever you attack doesn't matter, but the product always favor the less hindered side, so it always form below the isopropyl group. Since isopropyl is below the plane, the product is above the plane, which is the P there. In the same condition, if you look at the Q, if you abstract the proton, you have the anion formation. Then the anion is formed. The anion again have the same problem, it loses its chirality. So the reagent can attack from anywhere. So reagent attack the less hindered side. So it's again above the plane. So P and Q are same there. But the product is selective because it always avoid the steric crowding places. So the reaction is stereoselective and P and Q are same. So the answer is clearly A. Here the concepts you have to learn here is the shape of the intermediate. The anion is near tetrahedral shape but loses its chirality during the intermediate formation. Then let us look at the next question. They are asking the compound can undergo deprotonation very easily. They given the 4 different carbonyl system. First one is diketone, second one is diester, third one is ketoester, which is a beta ketoester, and the fourth one is allylic ketone there. So basically you are playing between the carbonyls. You have to find which one lose the proton easily in basic condition. So from the question of deprotonation and 4 different carbonyl system, you might realize the question is really about functional group versus acidity. The answer is A. Let us see how. Here I encourage you to know the fact that ketone is more acidic than ester. Let us analyze the possibilities here. Once the proton is removed, you have anion formation. So the anion is formed. So whether the anion can form easily or not is a real question. If your compound is the ester, the lone pair on oxygen, which is O-methyl, can delocalize on oxygen there, which is carbonyl oxygen. So what really happens is already negative charge is there. You cannot form negative charge near the negative charge, so it will repel each other. So the ester don't allow you to lose the H plus easily. The same condition with C also, it is also ester, same thing will apply there. But if you look at the D, it is possible it can lose the proton, but the anion is stabilized there. The anion also stabilized there by conjugation. But the fact is that it has less resonance structure than A, because A has more resonance structure since it has about 8 alpha hydrogens. So it's a more acidic when compared to all others. That's why our answer is A there. Here the concepts you have to learn here is ketone is more acidic than ester because of oxygen lone pair. That's all from this episode. I hope it was easy. Thanks for watching. If you have any suggestion, comment below. Stay tuned for next episode.